Good morning, everyone, or good evening, or whatever time it is when you're looking for. So, this video is about me demonstrating you a way to do Canary deployment using Google Cloud Platform technologies, in particular Cloud Build, Cloud Deploy, and the glue between them, which is called Scaffold. And I'm going to walk you through the application architecture that I try to achieve, a little bit about the source code, and of course some juicy demos, very simple demos. And then we're going to talk about little review about that. First, what is Canary deployment, right? So Canary deployment is in general, I Googled it quite a few times to be sure that the general consensus was the same of what we had internally in Google. First, Canary deployment comes from, like the historical name for Canary comes from people going into mines or caves with those little canaries, and if there were fumes of too much CO2, the little birds would die before humans. So they were used to get the birds to die before humans, which is pretty sad, but I can understand why. And we use canarying today for a similar reason. We want to try something out without getting too much responsibility into that something. So pragmatically, within code deployments, the idea is that the general population gets example.com version 1, 2, 3. And then a few people, it could be early adopters, it could be us developers or operators, get maybe a different endpoint, maybe the same endpoint in a different percentage, a Canary version, which is, I don't know, the latest version that we want to try it out. Usually when you say Canary, you actually allude to both of them being available at the same time in different percentages. And that's what I'm going to do into this demo. So I'm going to assume that you want to have, I don't know, 90% of example.com or the second latest version, the stable version, and a 10% or 20% or whatever, a smaller percentage of Canary. And you want them to coexist within the same endpoint. Now, if you are familiar with Kubernetes and load balancing in your favorite cloud, which is GCP, right? Then you know that you can very easily play around with endpoints. So you could have the Canary version, the stable version, an endpoint pointing to the first, an endpoint pointing to the second, an endpoint pointing to both of them. So the part of pointing to both of them is actually the easy one. Let's look about the application that I created a bit more into details. First, I thought that creating a single application would be too easy. So instead, why not create 3 applications? I started with 2, and then we had an additional need for simplification. And then I created a 3rd application, thanks to my friend Daniel. So app01 and app02 share the same fate. They're built in Python and in Ruby, respectively. And they're a simple homepage. Like, it's a simple page with a bunch of env variables that tweak what you see on the page. Think of it as a troubleshooting silly page for myself, right? So there is the app name, a little emoji, the version, and the target or the stage of it. You see target prod, etc. Then, if you want to curl these 10 times or 100 times, to count how many times it's Canary, how many times it's run. This is a bit lame. Initially, I started grabbing the last part. Then I thought, like, you know what? Let's just create a /status_z, which is a single liner, which gives me all I want: app name, version, target, and emoji. Otherwise, it would be so sad, right? Then I created a 3rd application. Actually, my friend Daniel and my friend Alex created it, a Node.js application. Ruby and Node are done with Docker. And Python is actually built with a build pack, because why not? I mean, what's in the folder stays in the folder. As long as Scaffold knows how to build it, we don't need to know what's inside the folder. It's very agnostic of what's in the folder, right? I'm thinking I'm the operator, and the developers do whatever they want into /apps/app04, for example, which is going to be the next app you are going to build, maybe in Python or maybe in Rust. Now, let's take on the second part of the deployment strategy. So, as I said, I'm using Google Cloud Deploy to deploy. Cloud Deploy inherits the build stage from something else. I use Cloud Build, but you could use GitHub Action or GitLab or whatever you want. The 2 applications that I built first have a very simple dev, staging, canary, prod progression. Like the targets in cloud deploy are consequential. So you have dev first, then staging, then canary, then prod. Then I'm deploying dev and staging into the dev cluster. I call it, I will not mention it because I don't care. This to me is my crash bin. That's the stuff I don't care about. And the canary and prod that I do care about are into the canary and prod cluster. So I have one cluster for canary, one cluster for deployment, for prod. That means that I have 2 GK clusters for those 2 versions. I got some feedback from colleagues like, Riccardo, this is a very niche solution because most customers will probably start having canary deployment and prod in the same cluster. That's how the App03 was created, and we tweaked the cloud deployment strategy to have canary and prod both into the prod cluster. So App03 deploys only to prod cluster, whereas App01 and 2 deployed canary and prod in 2 separated clusters. Of course, getting an endpoint or a load balancer that points to this is very complicated if this is in a different cluster, and it's easy peasy if they're in the same. So as you can imagine, the solution for App03 is much simpler. This is how Scaffold profile looks like. So Scaffold is a YAML file. If you don't know Scaffold, I really suggest you to do a little Googling, something like Scaffold. Well, actually, you don't need to Google it, scaffold.dev, and then delve into the documentation. What Scaffold does, as you can see here, it's simply you can create a YAML file from scratch. That's what Scaffold init does, and then you can tweak it. Okay, and then Scaffold will allow you to have a single point, which is a Scaffold YAML file, where you say, this is how you build it, this is how you deploy it. I don't know how you build it. What is the Docker file? In which directory it is? How do you deploy it? Where do you find the Kubernetes manifest? Stuff like that. And then I can say, hey, if you have the profile dev, staging, canary, and prod, you go into these subdirectories. We tweak the behavior based on these 4, thanks to customize. So that's a really powerful abstraction, because then you can say 90% of this. Oh, sorry about this. This is the wrong. This is the wrong one. This is the wrong one. Apologies. This is what we want. So you can actually have 90% of the code, which is the same for all targets, and then tweak the staging, canary, and prod to add a couple of labels or to add a namespace, to change the replica pods, etc. So what are the 2 solutions? As I said, historically, I created App01, App02, and I created a super complicated solution. I will call it solution 2. And then after some time, people say, well, Riccardo, this is too complicated. Just simplify it and put everything in the same. So for App03, the Node.js, I created the first solution. So what is the first solution? The first solution achieves canary strategy via pod splitting. So I have 4 pods. I think I just moved it to 5, but whatever. I have 4 pods in production. I have 1 pod in canary, and I have a single service pointing to all of this. Easy peasy. This is what Kubernetes did in 2014, right? Easy peasy. To keep things slightly complicated, I have this cloud deploy pipeline. So imagine that you have a timeline where you have your application app with version 1.0.0, and then you promote it to 1.0.1, nothing happens. Then you promote it to staging, nothing happens. Then you promote it to canary. Now the 1.0.1 is pushed into here, or at least, or actually, the replica set with 1.0.0 dies. The replica set with 1.0.1 is created, and the service points to these 5 pods. For a second, the 1 dies. Then you have a new pod, and then you have 4 green pointing to 1.0.0 and 1 yellow pointing to 1.0.1. Then if you promoted this as well, then all of a sudden these 4 pods will die, and any replica set with pods of the new version will get there. So as you know what I'm saying, this load balancer will point to these 5 pods, and eventually 1 pod might die, 1 pod might be recreated, and you will get a mix of those 2 versions. Now, this is very naive because first, nothing guarantees that 1 pod is as able to get traffic as another pod. 1 pod could be in a could get a request which is a bit, I don't know, further away, or the request could get more payload. So actually, this balance is not exactly 80-20 as I want to make it look like, but it could be 90-10 or 70-30 based on actual traffic. So that's why I call it naive pod balancing, because it works fine, it's super fast, it's super easy, but it's not very sophisticated, right? For sophistication, before the sophistication, let's start with the proof that this works. So how do we prove this works? Let's do a curl. What is it? HTTP, HTTP, punti barra barra. Let me copy this here. 146, 148, sorry for speaking Italian, 155 / So, as I showed you, without the status Z, the slash is very verbose. I could do pipe grep status, which I quite like it, but then I thought, like, you know what? Let's just create an endpoint which is just simple. Okay, so as you can see, here I have prod. Let's try 10 times. Oh, okay. Here you see one canary, right? I was starting to think that the script didn't work. And here you see, I actually changed the emoji between the two versions, just because why not? So as you can see in this example, I have 2 canary version 103 and 8 prod version 102 for app 03. So my Node.js has 2 different states for prod and canary. I could also have the same version, that would be boring, but at least I would always still see the target difference. So I hope I persuaded you, this works. Good. Let's delve into the complicated one. Oh, before I get into the complicated one, let me show you some metrics on Google Cloud logging and monitoring. So in logging, this is how it looks like. So you see, I've done some curves, and this is the status Z Easter egg invoked in Canary, blah, blah, blah. And this is invoked in production. So this is how the logs, I created a log. So every time app03 gets my slash status Z, it also logs it here. And then I created a log2 metric that counts this, and I created a metric like this. So look how cool this is. This is the Canary traffic, and this is the prod traffic, and this is Canary and prod. Let's see, in the last 1 hour. This is Canary and prod together. So as you can see, prod is 1.23 queries per second, and Canary is 0.27 queries per second. So the ratio is 1:4, 1:5. It's like 80-20% as I promised you. So this is actually working. How cool is that? Bingo. So now that I proved that this works, let's move to the second part of this, which is the complex solution. So first, what the hell is XLB envoy-based GF3? You really like to complicate our life, Riccardo. Yes, I do. So you need to understand that Google Load Balancer used to be a Google-only product based on Google-only technologies. Recently, we injected into its behavior envoy. Now, envoy, if you Google it, it's envoy proxy. It's what's it called? It's let me remove this. It's an open source proxy that was started by Lyft and is now used by many big companies, Google included. And think of it as a sophisticated proxy solution. Okay, that allows you to do many things, among which also carrying traffic splitting, etc. So that's what we are using for. And if you Google envoy-based load balancing GCP, you will find a beautiful page on Google Cloud which tells you which of these are backed up by envoy, which at the moment is the global external HTTPS load balancer, or XLB, as my friend calls it, regional load balancer based by it, and also the internal load balancer, if I remember correctly. So a lot of Google load balancer use envoy. Very few don't. For example, the classic load balancer doesn't use it. It's still using the classic Google technology for that. Now, to understand this, NGFE level 3 is the Google solution, which is backed by Envoy. XLB stands for External Load Balancer. So I hope this explains it. And with proper traffic splitting, so this is traffic splitting done well, as we'll see in a second. So let me show you this screenshot a bit better. Oh, okay. So this should be better for your eyes. You have a Git repo. The Git repo builds app01 and app02. Remember the app03 follows a different path. Dev and staging, we don't care. Python above, Ruby below. What we care is when the application gets into the Canary and prod targets. When it happens, sorry, my device needs booting for 1 hour. Sorry about that. Canary and prod goes into the Canary and prod cluster. On the other hand, so that's one part of it that you achieve by kube controlling and doing the cloud deploy stuff. On the other hand, I use gcloud to create the two load balancer, app01 and app02. The load balancer has a public IP address and has as children some backend services. Those backend services, and it has a URL map which is configured to balance between those backend services. And the backend service is something where you say, hey, attach something to me. What do you attach it? How can you attach some pods to a backend service? Actually, you cannot. Until some very clever person in Google invented a NAG, network endpoint groups. Network endpoint groups, what are they? The way I see them is it's a virtual RJ45. So think of like a network patch cable, which you attach it to a switch here, to a router here, and it allows networking between those two, right? So similarly, a NAG is a virtual RJ45, which allows you to attach it to something and to something else, where that something can be a lot of stuff. It can be a backend service, it can be Kubernetes services, it can be a Cloud SQL, MySQL or Postgres endpoint, and so on and so forth. So it's something which needs connectivity, and you can connect those two somethings which need connectivity, which is with this virtual cable, right? That's at least how I see an NAG. So what we need to do is we need to attach app02 Canary to all the pods in the Canary target here, or actually to the pods in the Canary cluster, which verify certain behaviors. For example, they belong to app02 and they are of type Canary and not of type prod. Okay, this is what I want to achieve. How do I achieve this? Well, let's go back to my slide. So if you're curious on how to achieve it, you can just click on the same solution here, which is in my GitHub repo. My goodness, this is taking a lot of time. Let me do it this way. Under Kubernetes solution 2, you will find a README, which has a lot of stuff. This is the solution provided to me by my friend Daniel, and I apply this solution to my complicated solution for each application, right? So first, if you want to do it yourself, you follow this README, bingo. If not, you look at my code, you create health checks, backend services, you enable the gateway API. This part can take like 30 to 60 minutes to become fully functional. And then you apply a bunch of manifests. Y8, app01, app02, Canary prod in Canary and prod services into Canary and prod cluster, which is Canary cluster, prod cluster, Canary services, prod services for app01 and app02. Now, so these are 8 things. To be completely fair, the Canary service should go into the Canary cluster, the prod service into the prod cluster. So Canary prod should always be aligned, right? But actually, I thought, what if in the future, to have a higher reliability, I want to have a couple of pods of Canary in prod and a couple of pods of prod in Canary? Why not? That should be possible. Like, it's just a Boolean. It's just something you can enable with a Boolean flag. So that's why this wants to be generic. Now let's get to the complicated part. Remember when I told you I need to attach this virtual RJ45? How do I do this? Well, the core of the scripts is in here. Let's see if I have it already somewhere. No, it's not here. Yes, bingo. It's here. So for every cluster, for every type of traffic, I call the service name like this, blah, 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 application name, dash solution to service, which you're going to see later on my Google Cloud part. Then you do kube control on prod or on Canary. You call the service name with the name that you have here. I just detected it here. Then you expose it as a JSON, and that service neg objects contain an array of usually 3, maybe 4 neg objects with network and endpoint groups with this awful name. You see, blah 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 blah. This part is the part that I don't know. So I interrogate with kube control the service neg 1, 2, 3, and then I say, hey, what are your negs? These are this. Why 3? Because it's 1 per zone. I mean Europe West 1, and so my pods, because I have a regional Kubernetes cluster, could be in B, C, and D, which are the zones of Europe West 1. I know there's no A. But if you were in US Central, then you might have 4. For each one of these, I read this, and I say, hey, gcloud, add to the backend that I just created, or I just named whatever I wanted, service, blah, 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 add this neg that I just found. So this is the weaving, where I'm weaving into this backend. Let's go back to here. No, this is ugly. Let's go back to here. This is where I'm weaving to the app02 Canary all the pods that I find in the Canary cluster here. And I'm not actually attaching the pods, because if I attach the pods could explode, and then the weaving would die the moment you change the application. But I'm weaving actually the service with a selector to those pods. So the pods change, but the service doesn't die. And as long as the service doesn't die, you will have it referred correctly. Okay, finally, this is the complicated part. Then you create a URL map, which is shown in here. I don't know if I can zoom this a little bit. Let me see, Control plus. No, I cannot zoom this because it's an image. But here I have a URL map where I'm telling her, hey, by the way, use backend service Canary for 22% and prod for 78%. And since I'm a bash guru, I actually have a bash variable, so I could change it over time. And that's my next demo. Then HTTP proxy, target HTTP proxy, and forwarding route, which has the IP address. This is how you build a Google load balancer. Now, how do we test it? Well, we do a lot of curls, right? Like we did before. So let's try the demo. I failed the previous demo. Let's see. Okay, clear. So the difference between this demo and the previous demo is that I cannot do the demo with the IP, but I can only do the demo with the URL. And since doing this has some problem, bingo. So as you can see, I'm curling. What is in curl example is very simply this. I give it a default IP and a curl-h example.io. If I do this here, it will not work for a very mysterious reason. I think it's, but I don't know. At least it didn't work. It always gives me prod for a reason I don't understand. But if I embrace it into the script, it will work. So I hope you don't feel I'm cheating on you, but that's actually working. And if I do 10 times, which is a script I created that does something, of course, 10 times, you can see that I have 3 canaries and 1 prod. And if you want to be completely lazy, you can do sort dash uniq dash c, and we can actually count them. As you can see, 9.1, 4.6, 2.8. Okay, I don't like this, but this is what curl gives on a Mac by default. So I have proven to you that this does work, even in the complicated solution. Why do I need to do the curl-h? Well, that's because the HTTP, this is a layer 7 solution. This is an HTTP load balancer, so you need to give it a name. You could say, but what if I give it an IP? If you give it the IP, he will not be able to choose the proper backend service, but you can only give it one backend service. So I can make the IP always point to Canary or always point to prod. But if you want to point to both of them, then you need to have an IP. And of course, nothing prevents you to attach the DNS to that IP, so you can just do a simple curl to the DNS. That's of course working, but it's it depends. Like the last mile of DNS attaching is quite complicated. So I've done it for myself, but cannot make you do like myself because maybe you don't have my same DNS provider. So that's why. So source review, it will take probably 1.5 hours to show you all my code. So I'm not going to do it. I'm going to give you some pointers. First, if you want to do it, what do? Well, you look at my code. Let's see here. And then you have a README, which gives you a very high-level explanation of what I just explained to you. Okay, this README is quite equivalent to the slides, and it has actually a lot of images from the slides. So the README is the read version of the slides, or of this video, nothing more, nothing less. But if you really want to go through it, you click on step-by-step guide. And then I don't want to scare you, but this is the table of content. So you need to run a bunch of scripts, 0, 0, 0, 1, etc., etc. And then you have a setup part, the execution of the scripts part, and then a number of labs. The labs is where you need to do stuff manually on the UI. Actually, the labs are actually quite fun. So usually when you get to the lab, you will have a lot. I promise you, you're going to have a lot of fun doing that. So there is the boring setup and the fun lab. Okay, these are the scripts you need to run to set up the infrastructure. So you get from the boring setup gcloud and APIs to the fun stuff like create the build triggers and create the deploy setup. To do so, you just need to copy the environment.sh dist that I created. You copy it into .dev.sh and then you edit away these 4 numbers. People are like, oh my God, why bash scripts and not Terraform? Well, that's a very good question. The problem is that Terraform alone wouldn't be able to do this stuff. It would have to execute a lot of bash scripts nonetheless. So it would have to have used a lot of local exec provisions to make it work. Think of the weaving of the RJ45s, right? And also the Kubernetes CRD provider is only alpha today. Maybe in a year time when the Kubernetes CRD provider will be in a better place, we can do this stuff. And maybe the gateway API will do the weaving by itself, because I'm pretty sure the gateway API will catch up and will do that part automatically. But I promise you the next project, I'm going to probably plume all the way up because I'm already working on it. Keep looking for it. Review. So what are the lessons learned? Lessons learned is cloud build and cloud deploy really work pretty well. And they allow you to achieve a very easy Canary solution with little effort in a single cluster, or with some effort into different clusters. Scaffold, together with profiles and together with customize, are really playing together very, very well. And in my code, you get an example, maybe a bit complicated, but a working example on how to get Scaffold profiles, customize, cloud build and cloud deploy all together. It's an end-to-end, quite sweet solution, in my opinion. Then this is my turn to apologize. Probably I shouldn't have given you two solutions for 3 applications and all of it in the same project. Probably I should have kept it simple and given different branches. Well, this is a lesson learned from me. I promise you I will not make the mistake a second time. I will try to keep it simple next time. Last thing to be said, Kubernetes and GCP are moving fast. Each one is trying to catch up with the other in a way or another. So it's, sometimes at a certain point in time, a certain solution is not fully compatible with another. That's why you need some bash scripting. So this is a way to look at it. The other way to look at it is in 6 months' time, I'm pretty sure the gateway API will be in a different place, and half of my bash script can be thrown away, and I look forward to throwing them away. Okay. Next step, well, in the future, I would like to have blue-green deployments. maybe deploy to Cloud Run, maybe add deployment verifications, and most importantly, this was suggested by a colleague of mine, doing a progressive rollout. So doing something like inject only 595, then maybe look at the deployment verification. If it's correct, wait, sleep for 1 minute, and then move it to 2080 or maybe to 5050, then 9010, and then 100-0. And maybe you can do this programmatically. It doesn't take much. I just need to abstract the YAML from the script 15 into a place where I can just bash script around it and move this, or statically put it into 4 folders like I did in this kind of like, as you see in this slide. Maybe add some monitoring to the mix and maybe interrogate the monitor and say, hey, monitoring, how does my application look like? By looking at the logs. God knows. There are so many things you can do in the cloud. It's so fun. It's so much fun. And if you have any comments, please put them in the comments below in the video. One last thing, thank you. I really need to thank 2 people, my 2 angels, which are Alex, who helped me on Customize and Node.js and Scaffold, and Daniel, who helped me on Kubernetes. And trust me, it was a long ride. So thanks, Alex, and thanks, Daniel, for your help. This is all. If you have any questions, one last thing, there is also a Medium article about the same thing. The Medium article is quite similar to the README that you find in here. No, not much different from the main README. The only really different documentation part, apart from this video, is the step-by-step guide that you have here on top. This is where you want to get your hands dirty, step-by-step guide. You want to know how it works? Listen to this video, look at the README, read the article on Medium. They're kind of equivalent. Okay? Thanks very much for listening. I will stop the recording now.